Hi, very good afternoon. So today we'll be discussing on GeoGebra. So once we open it, so you can see the default options. You can change to geometry, 3D calculator for 3D geometry. So by default, we'll be discussing on the graphing calculator part. So on the left side, you will have the option. Anytime if you want a keyboard input, you can get the input function keyboard. Or if you want to use a normal keyboard, you can do that. So let's start with a point. So generally, if you want to mark a point on the XY coordinate system, you can select a point and you can mark it. So you can see that the points are being marked like this. And if you want to find a line joining these 2 points, what you can do is you can select the best fit line. So I have selected these 2 points. So automatically the line joining these 2 points you have got. And if you go back to algebra, you can see that you can see both the points being marked and also the function, which is the straight line y is equal to mx plus c. That is the general equation of a line. So, like the initially we can discuss about points. Now we have a line and you have an equation of line, right? So we can go to the how we get this particular equation of a line. So to just refresh the screen, I just change an option and go back to the graphing calculator. You can see that you got a straight line joining 2 points directly. If you want to insert a straight line of the form y is equal to mx plus c, you can do that. So y is equal to, let me say, 2x plus 3. So what is the significance of this 2x and 3? So the value before x, which is the coefficient of x, is the slope of the line. And in technical terms or in mathematical terms, you can tell that it is tan theta, where theta is the angle made by the line with the positive direction of x-axis. Now you will understand more when I change the value of this. So let me try with minus 2x. So what has happened is the inclination has changed in such a way that the theta, that is the angle, is in the second quadrant. So that is greater than 90 degree. So for all values, negative values, it will be a second quadrant angle which is greater than 90 degree. And for all positive values, the angle made by the line with the positive direction of x-axis will be less than 90 degree. So that is nothing but the slope tan theta. So specifically, the value 3 is nothing but the y-intercept. So if you see, if I change this to 2x plus 1, automatically you can see that the y-intercept has changed to 1. That is, the line meets the y-axis at the point 1. So if I change this to 2x minus 1, automatically the line will be meeting the y-axis at minus 1. So a point slope form is y is equal to mx plus c. So the c will be the y-intercept and m will be the slope, which is tan theta. Now for max teachers, you already know the value of tangent. So for example, if you need a line with an inclination of 60 degree to the positive direction of x-axis, so tan 60 will be root 3. So let's try that. So if you are using a keyboard input, either you can use the keyboard from here, since you have a touch option and you can directly plot the square root function. So I'm giving root 3x. Yeah. So you got 60 degree. Now, if you want to have a y intercept, so if there is no y intercept, automatically it will be passing through 0, which is the origin. So if I add a y intercept, 3 root 3x plus 1, if I am just changing it to negative root 3x minus 1, automatically it passes through minus 1 on the y-axis. And if I change this value to negative, you can see that inclination is greater than 90 degrees. So this is nothing but tan 120 degree, which is tan of 180 minus 60 minus tan 60. So this way, by knowing the point slope form, you can reduce any equation of line of the form y is equal to mx plus c. Next shape we will be discussing is nothing but a circle. Based on the equation of a circle, the general form of an equation of a circle is x square plus y square is equal to r square. So x square plus y square giving radius of 3. So the 3 square will be 9. So you got a circle with radius of 3. So now if I change this to 16, radius will be 4. Now if you need concentric circle, just add an expression. Automatically, you can just add x square plus y square. So x square plus y square is equal to, will have 3 square 9. So you have two concentric circles, one with radius of 3 and one with radius of 4. This way you can plot multiple circles and you can discuss about how, and this all circles are centered around the origin. And the general form of an equation of a circle with any other point as center will be x minus a the whole square plus y minus b the whole square is equal to r square. So if you change that automatically, so we'll try one I'll just add an expression. So let me try with x minus 3 the whole square plus, let's say, 3, 1 will have the center. So that will be y minus 1 the whole square. So y minus 1 the whole square. So now the center is 3, 1, and we'll give the radius as so 2. So the radius 2 square will be 4. So you can see that this circle is centered around the point 3, 1. So to plot 3, 1, I'll just go back to the tools. I'll choose the point 3, 1, which is here. You can see that this circle is centered around 3, 1, and it has a radius of 2. So you can see the distance, which is 2. So I'll plot one more point here. So you can see this is the point in the circle. The radius is 2. So this way you can explain about the circle, that how it is formed, the radius, the shifting of the origin as center, everything you can directly do. Now we'll change the next topic to conic section. So generally, if you have a equation of a parabola, so generally we'll try, let's try with y is equal to x square. So y is equal to x square. I'll just take the keyboard. Y is equal to x square. You can see that it is a parabola which is symmetric around the y axis. Now I'll just change it to y is equal to minus x square. It is symmetric around the negative direction of y axis. Now what happens if I change the coefficient? So value, if I add 4 here, it is converging more towards y axis. So if I add a value less than 1, so which is zero point 0.5, it is diverging. Again, it depends on the equation of a parabola. Y is equal to 4x square. A general equation will be equation of the form y is equal to x square will be giving you parabola symmetric around y axis. So that directly takes us to the next point. If I just change the function, x is equal to, let's say, y square. So what will happen? It is getting symmetric towards x-axis. Again, if you change x is equal to minus 4y square, it will be automatically symmetric about the negative direction of x-axis. So again, if I change this to minus 4y square, it is converging. And if I choose a value less than 1, which is zero point 0.5, or let's say even less than that, 0.01, so you can see the divergence scale is too much that you can't even see. So I'll make it 0.1. You can see now. So now 0.2, it is converging more. 0.3, again it's converging. 0.4, more converge. 0.5. So now minus 1. So you can see this way. So this way you can uh, discuss about multiple parabolas. All four parabolas will say. So y is equal to x square form we have given. Y is equal to minus x square given, x is equal to y square. So we'll just see one x is equal to, let's say, 2y square. So automatically it is converged to the positive direction of x-axis, and we'll have one more. Let's say y is equal to 3x square. So you can see it is converged towards the positive y-axis. So this way, all different formats. And now if you want to discuss about an ellipse, you can try to use equation like x square by a square plus y square by b square is equal to 1. You will get an ellipse. So this way, conic sections can be taught to children easily. Now we have discussed about point, a line, equation of a straight line with point slope form, y is equal to mx plus c, where m was the slope and c was the y-intercept. Then we discussed circles and parabola. We also have options like 3D calculator. So if you want to discuss a point in a 3D geometry, let's say -1, or let's say 1, 2, 2. So 1, 2, 2. So you can see that this point being taken is first, initially it will take 1, 2 on the xy plane. So 1, 2 will be here. I'll just mark the point 1, 2 using the tools, a point. So this will be, so I'll use algebra itself for my convenience. So that will be 1, 2. You can see the 1, 2 is on the plane, and you can see that in the 3D geometry, I have chosen the next plane. So 1, 2, 2. So what is happening from here to here? There is a vertical distance of 2 towards the z-axis. So this way that you can introduce concepts of 3D geometry as well. So again, I am choosing another point. Let's say -1, 2. So I'll change this to -1, 2, and let's say 3. So automatically you can see the point is minus 1, 2, 3. So to get the significance of minus 1, 2, I'll just mark minus 1, 2 separately, minus 1, 2. Automatically you can see this minus 1, 2 is in the point on the xy plane. From there, perpendicular towards up in the z direction, you will get minus 1, 2, 3. This way you can introduce concepts in 3D geometry as well. Not only that, if you want to go back to the graphing calculator, you also have a format called table. So if you want to plot the points directly for lower class children like 1, 2. So 1, 2, you have a point 1, 2. 2 minus 4, you have a point 2 minus 4. Now if you want to join these 2 points and get a line, you have the best fit line. I'll just draw these 2 points. Automatically, we'll get a line. So instead of going directly to the points, you can also mark the points using the ta table format. Automatically, you will get the format. And if you go back to the algebra, you will get the equation of a line. And if you want to have these points in an Excel sheet and directly plot, that is also possible. So what you can do is you go to this table, you import the data in the format of a CSV file. So I have added a CSV file, automatically it will import the coordinates. Now, if you want to have a line, you can mark the show points, it will show points. If you want to have the regression line, go to the regression line, it will show you the y is equal to ax plus b form. If you want to plot, automatically you will get the plot of these line. So this way you will be able to ensure you get the points using a tabular format and you plot the line. So this also can be done. So you can actually use multiple options. And again, if I want to take a chapter relations and functions, if I go to this function, so if I go to mode x, I'll just use mode x here. Automatically, you will get the equation of mode x. Now, if I want to show to students how mode x plus 3 will work, if I add 3 within the function, it will shift the orientation to the point with centered around minus 3, 0. Whereas if I change the point to mode x plus 3, so if I change to mode x plus 3, automatically what happens is the function mode x plus 3 will be inserted. You can see being inserted on the y axis. So mode x plus 3, it will shift towards the y axis 3 points. So now if I give mode of x minus 3 plus 3, mode of x minus 3 plus 3, if I add a function, you can see that it has shifted both towards 3 as well as towards 3 on the y-axis. So this way you can ensure that mapping of functions like specifically like mode x and other and how it shifts when you add functional values, it can be ensured. So teachers can use GeoGebra to teach relations and functions. And if you want to teach linear inequalities, you can use the graphing calculator and you can use linear inequalities. For example, x greater than 3. You can see that x greater than 3, the region has popped up. You can move and see. Now, if I want to specifically specify x less than 3, x greater than 3 and x less than 5. So x less than 5, automatically I'll just remove the slider. So I'll just show again. So first one, you got x greater than 3 and the next one is x less than 5. Automatically you can see that the region which is being bounded by x greater than 3 and x less than 5 is being shown. If you want to hide this particular region, you can hide. If you want to show this region, you can show. Anything can be done. Now, if you want to add the y coordinate as well, y greater than 3, you can add. So automatically you will get a y greater than 3 and you will also say y less than 7. So now you will have a region which is bounded by all these 4 equations. So now you can move this. Automatically you can see the slider. You will get y greater than 3 and y less than 7, which will be this region. If you want to remove these regions, you can remove. Any region can be removed to show the other 2 regions. So this way you can teach linear inequalities as well. So you can teach coordinate geometry, 3D geometry, equation of straight lines, conic sections, and you can solve a system of linear equations to find the solution to x and y. And you can also teach linear inequalities. So in one way, almost all the chapters associated with mathematics, you can actually introduce through GeoGebra. Thank you so much.